Hi, this is a recording or a demo for week 2, and we're going to be talking about map projections in this demo. Um, to start off with, I have ArcMap up and on my screen, and I've loaded in the world imagery that we've already gone over how to load. A couple things we're going to do is we're going to go over how to change the projection of the map project, and we're also going to go over how to change and define the projection of individual data sets. First of all, when we zoom out here and we see the world imagery, hopefully you can see that if you remember back from the PowerPoint, there are 3 types of projections, conical, cylindrical, and planar. And you might guess that this is a cylindrical projection when we load in the world imagery. And you can tell that mainly because the data is square. So the piece of paper, when they made this projection, was wrapped around the globe in a cylinder, and you unfold that globe and it becomes a square. Now, one thing we learned from the PowerPoint about cylindrical projections is these types of projections are pretty accurate around the equator, but the farther you go north or south of the equator, things tend to get really skewed. Area is off, distance is off, direction is off, and shape is off. For example, look at how big Greenland is. Greenland is not near that big. If we were to superimpose Greenland on top of Canada and the United States, it would take up all of Canada and the United States. Greenland is not near that big, and the reason it appears that big is because the type of projection we're using, and it's way north of the equator, so it is stretched out immensely. Also, notice Alaska and how it's oriented to the United States. That is not how Alaska is oriented, and here in a minute we'll see what the Earth really looks like when we change the projection. So remember, first, ArcMap takes on the projection of the very first piece of data you add to it, and the very first piece of data we've added is the world imagery. So if we double click on our data frame properties, we will see that our map is projected at WGS84 Web Mercator. And again, the reason it is projected to that is because the world imagery was projected to that. So let's just go ahead and see. Remember, there are 2 types of coordinate systems, geographic and projected. We are currently in a geographic coordinate system right now. Let's go ahead and see what the world looks like when we change the projection to a projected coordinate system. And I'm just going to select a projected continental North America, and I'm just going to pick a North America Albers equal area conic. Now you can see what happens when we do this. This is a North American projection. That means if we're going to make a map of North America, this would be a projection that we would want to use. And if we zoom in now on North America, once it gets done drawing here, you will clearly see Greenland is not near as big as it was before, and Alaska is oriented completely differently to the United States, which is how it should be. Hopefully my map will get done drawing here. Sometimes this takes a while with the data sets that we're loading. Not sure what's going on here. I'm going to pause this recording while I load this so that you don't have to sit here and stare at me while I'm waiting for this. So I'm going to pause it and we'll be back here in a second. Okay, so we're back here, and as you can see, we've changed our data frame, so we've changed our map to a projected coordinate system, and now you can see how Alaska is oriented with the United States. You can see that Greenland is not near as big as it was in the cylindrical projection, and the Earth, for lack of a better term, looks as it should. Now, would we want to use this projection if we were going to make a map down in South America? No, we wouldn't. Is this projection good for North America? Yes, it would be perfect for North America. So it's all about what kind of map you want to make, where you're mapping, that will determine what type of projection and coordinate system you want to use. And remember, did we change the projection of the world imagery? No, we did not. In fact, if we click on it and look at the properties of it, we will see that it is still in Web Mercator WGS 84, but however, our map is now in North America Albers Equal Area Conic. And I may pause this recording again because it seems like it's taken a long time for the properties to open up the world imagery, so let me pause and we'll wait for this to open up. Okay, so we're back. For whatever reason, the imagery with the labels wasn't letting me open the properties of it, but I loaded in the world imagery without the labels, and as we can see here, if we look at the properties of the world imagery, it's still in WGS 84 Web Mercator. We haven't changed that at all, but we did change the layer properties of the map, and it is in North America Albers Equal Area Conic. So the thing to take away from that is that ArcMap has what we call project on the fly. And what project on the fly means is the software has the ability to be in whatever map projection you want, and it does not have to match the data that you have in your map, which is good. So you can have as many data sets as you want, and we're going to see more of this here in a second, in whatever projection you want, but we can tell the map to be in whatever map projection we want, and it does the mathematical calculations behind the scene and makes all of that mesh and line up, and that is what we call project on the fly. So that's an important thing to remember about ArcMap. So what we've just gone over is loading in the imagery. We've gone over how to change the projection of your map without having to mess with your data. And the way we do that is we double click layers, go to data frame properties, and we pick whatever projection we want to use. Now let's look at some data and figure out how we can change and define the projection. I'm going to hit the Add Data button. I'm going to look at some data here in the Projections Lab folder that you all should have, and we're going to load in the states. So this is a vector file. Remember, there's three types of vector files: points, lines, and polygons. This is a vector file of the United States showing the 48 states and Alaska and Hawaii. One other thing to point out, we're in a North America projection, which is what we would use if we're going to make a map of the United States or North America. What if we wanted to make a map of Alaska? Again, would we mess with the projection of any of the data? No, we wouldn't. We would simply double click layers. I'm going to go to the projected folder, Continental, North America, and look, there is a Alaska projection. So let's go ahead and click on that and see what our map looks like when we choose that projection. So now what you can see is Alaska is oriented sort of north, south, east, and west, and the world is oriented around Alaska. So you can see how the map changes when we change it to an Alaska projection. So in other words, the 0, 0, or the origin for this map is in the middle of Alaska, and everything else is drawn around it. Okay. Would we use this kind of projection to make a map of Russia or South America or Australia? No, not in a million years would we use this, but it's perfect for Alaska. It's accurate, distance is accurate, area is accurate, direction is accurate, shape is accurate, for Alaska, but probably not accurate for a lot of other places around the globe. So let's go back to our North America projection. Let's see here. Yep, North America Albers equal area conic. And now we're back to our North America projection. Again, have we messed with the projection of the states? No, we haven't. If we double click the states and go to the source tab, we can see it is projected in a geographic coordinate system, and the datum it's using is North America 83. We have not changed it at all. Again, our world imagery is still in WGS 84, but our map is in North America Albers equal area conic. And so what ArcGIS is doing is it's taking the world imagery in the states and it's meshing it into this North America Albers equal area conic. And how is it doing that? Again, because the software has what we call project on the fly. Okay, let's talk about what if you add a piece of data and it doesn't line up with our map. So for example, if we hit the add data button, I'm going to load in this cities shapefile. Now the first thing you're going to get here when we load in this cities shapefile is it gives us a warning here, and it says the following data sources you added are missing spatial reference information. Basically what it's telling you is this piece of data you're trying to add to your map does not have a map projection. So it can add it to the map, but it's probably not going to line up. And as we take a look at this data, we can see, well, at first glance, it looks like the cities do line up. Let me change the symbology for our cities here. Looks like things line up, but if we zoom in a little bit, let me just change the projection of my map here. So we can see, what city is this here? This is Cheyenne. Cheyenne is nowhere near where it should be. It's clear down in Colorado. And if we zoom to the cities layer, notice we've got some cities that are down in Mexico. This one that's in Florida is out in the ocean. So is the one in Louisiana. You can see Honolulu, Hawaii is clear out in the ocean. So something is going on here to where the cities are not lining up. It looks like they're all shifted down from where they should be. And again, if we look at the properties for these cities, look at the projection, it's undefined. That is the worst thing you can have when you're working with GIS data. Your shapefiles always need to have a defined projection. The other thing you need to remember here is that you cannot just define it in whatever you want. You have to ask the person who gave you this data, hey, what projection should this be in? You have to look it up on the internet site where you got this piece of data and see if it tells you what it should be in. Somehow, some way, you have to figure out what projection this shapefile should be in so that you can get it to line up with the rest of your data. In this particular example, I'm telling you, and this is in the lab, I'm telling you what projection this shapefile should be in, and it should be, I believe, North America Lambert conformal conic. So let's go ahead and give it that projection and see what happens. Now there's two tools you use in terms of projections, and if you have a shapefile or a piece of data that does not have a map projection, the tool you are going to use is called Define Projection. So I'm going to open up the search window here, and I'm going to type the word define in. And as you can see, the third tool down, Define Projection, so we're going to go ahead and open that up. Our input data set is going to be the one that doesn't have a projection, which is the cities. Now we need to give it the projection, and again, you can't just give it whatever map projection you want. You have to figure that out from whoever gave you the data, or wherever the website you downloaded the data from, or if you have a teacher like me, hopefully they will tell you what projection it should be in. And right now I'm going to say this piece of data was created in a projected coordinate system, continental, North America, and it is North America Lambert conformal conic. So watch what happens to the cities. Notice where they are now. Watch what happens when we click OK on this tool and we let it run. Take a little bit for the tool to run here. There we go. And as you can see, the tool worked. We get our green check mark, and look at what happened to these cities. They have all now shifted up. It looks like everywhere the cities should be where they're supposed to be. Let's look at the one in Hawaii. Yep, the Honolulu is no longer out in the middle of the ocean. It's where it should be. If we zoom in on Wyoming and Colorado here, Cheyenne looks to be where it should be. I believe this is Fort Collins. Yep, Fort Collins is about where it should be. So everything is back, lined up, and ready to go to make our map. Again, our cities is projected. It was undefined. We fixed that. Now it's in North America Lambert conformal conic. The states are in GCS North American 83. The world imagery is in WGS 84 Web Mercator, and our map, our overall map project, is in USA Contiguous Albers Equal Area Conic. All three of these pieces of data have a different projection. Our map is in another projection, and again, the reason that works is because ArcMap has project on the fly, and it does the mathematical calculations between the world imagery, the states, cities, and it makes it all mesh up with our map projection, which is, again, like I said, was USA Contiguous Albers Equal Area Conic. And remember, that is all due to project on the fly. The last thing I want to show you is what if you want to change the projection of a shapefile. Let's say someone emailed myself or you and said, hey, we want this city shapefile, we need it for a map, but we need it to be in North America Albers Equal Area Conic instead of Lambert conformal conic for whatever reason, okay? Now, if something already has a defined projection but you want to change it to something else, the tool you're going to use is called Project, Project. So I'm going to type Project into the search window. And which one are we looking for here? Project Data Management, that's the tool we're going to use. So our input data set, again, is going to be the cities. The input coordinate system, we've already defined that as being North America Lambert conformal conic. Remember, we did that using the define tool just a few minutes ago. It's going to make a new shapefile. Okay, so we need to tell it where to save this shapefile, and I'm just going to put it in my week 2 folder. So let's see, class, for me this is classes, Geog 1100 day, week 2, projections lab data, and I'm going to call this cities underscore RPJ to let myself know that I'm reprojecting this cities shapefile. And then we need to give it the projection that we want it in. So projected, I want to change it to a projected coordinate system, continental, North America, and I want to turn it into North America Albers Equal Area Conic. Okay, so it's currently in Lambert conformal conic. Person I talked to wants it in Albers Equal Area Conic. So that's what this tool does, is it changes from one projection to another. Click OK on the tool and let it run. You can see it added the new shapefile to our map. It's lining up perfectly where it should, but if we double click on it, look at what projection it's now in, North America Albers Equal Area Conic. Okay. Okay. Now again, it's lining up exactly where it should on the map, and the reason that is because we used a tool to change it to another projection. But remember, ArcMap still has project on the fly, and that's why it's still lining up where it should, because ArcMap is doing the calculations between Albers equal area conic and what our map is in, which is contiguous Albers equal area conic. A little bit different, so there's some calculations it has to do to make it line up, and that's why everything is lining up here. So we have 4 different pieces of data, all in 4 different projections, and again, the reason they're lining up is because ArcMap has project on the fly. So the biggest things to take away from this demo is one, if you want to change the projection of your map, you don't have to change each individual data set. You just have to double click your layers or your data frame properties and you can change it to whatever projection you want. And that will work as long as every piece of data in your map has a defined projection. If one of these didn't have a defined projection, it wouldn't be lining up right now, and we would have to fix that. And again, what tool we use to fix that if a piece of data does not have a defined projection is we use the define tool. Okay. Can you define it in whatever you want? No, you can't. You have to figure out what it should be in from the person that gave it to you, from the website, from wherever you downloaded it from, and then you use the define tool to define it in whatever it was made in. Once you do that, it'll line up perfectly just like what happened in the demo here. If you want to change a projection of a piece of data, remember the tool you use is project, and that changes the piece of data's projection from one to the other. Okay. I hope this demo was useful. Again, email me or call me if you have any questions, and hopefully this should allow you to work through the lab and get everything done correctly. So thanks, and we'll talk to you later.